So okay, so with the transition from 1 to 0 and 0 to 1, okay, I have drawn it as usual. In most cases we actually draw it with perpendicular edges. The edges, perpendicular edges actually mean that the change is instantaneous, that it happens right away. It doesn't. There is a bit of a slant here always. Why there is a bit of a slant? Because if you imagine that this is the, if you imagine that this is the time quadrant, this is time, then obviously it takes a little bit of time go from 1 to 0 and from 0 to 1. This is always a bit of a slant. So in effect, all right, it kind of looks like this, that instead of having exactly perpendicular things, we would rather have something to the tune of this. A slant, then a 0, say coming up here, then a bit of a slant again, like this. This is how it actually normally looks like. But because these are so small increments or decrements, and we need to work with the logically speaking, we need to work with the actual, sometimes with the levels and stuff, work with uh, the clock signals being even. So that is why we sometimes ignore these slant edges and we just say that it is like this. Except the fact that when you will see timing diagrams, you will see that the edges are looking like this. Okay, but here we were concerned with edges. Sorry, beg your pardon. We were concerned with levels, so I drew it like this. Now, basically, when you are making a device that is triggered and activated and it stays on activated according to the levels, it stays on for some time, whether you like it or not. So, for example, if you read from a memory element and then you want the memory element not to be read again, you have to wait until the level is over. Then it comes to the edge and then goes to 0, then it is off. So, as you can imagine, it's a waste of time. Not only that, it's an undesirable effect, because you are wanting, well, you want the input to be instantaneous. It is available, you read it, then off. But that's not happening. It is staying on being available for some time, at least until the time it is enabled, that is all this time here, it is on. It may actually be on for the entire period that it is actually 0. So that means until this time it may be on. At least for this time it is on. And you don't want that, because you want it to be read and then that's it, stop it. Right? So here the latches have a big problem because they are level triggered. So what we have is a flip flop, and a flip flop is edge triggered. So edge triggered means that this CLK signal that you see, these are these edges. It's either a falling edge or a rising edge. That means a negative edge or a positive edge. Positive edge 0 to 1, negative edge 1 to 0. And as you know that for a set reset latch, it works when the enable signal is 1. So this is connected to the positive edge of the clock. So for a brief period of time, the signal is 1 because of the rising edge, and the flip-flop works. And the flip-flop works very similar to the SR latch. But set reset is 0, it is a hold position, hold. That is, the output does not change. It was the previous output. As long as it is 0 is 0, it is always the same as before. Similarly, if you reset it, setting S to 0 and resetting to 1, then it comes out as 0. And similarly, if you set it, setting the reset to 0, then there will be a set signal which is 1. That's what comes out. And as usual, 1 and 1 is undefined, because it is undefined because it makes certain amount of sense, because although may not by design, but the thing is that it although by design or not, it makes certain amount of sense, because you are either setting or resetting, you don't do it at the same time. So if you want to set and reset as something both at the same time, for example, I talked about the toggle button of the a toggle button on off switch of the TV. Imagine if that TV switch you wanted it to be off and on at the same time. How would you do that? You can't do that. So if set is on and reset is off, then if you want to do set and reset at the same time, that's actually not very feasible. So it's undefined. So look at the state diagrams for these. If for both these to be zeros, QT is held back as it is. In QT plus 1, which is the next input, that is, the previous input is maintained. It's a hold position. And then with this, okay, if the reset is set to 1 and the previous output is 0, then also it becomes 0. The previous output is 1, then also it becomes 0. And with the set, the opposite happens. Whatever is the previous output, the next output will always be set, that is 1. And obviously these two are undefined. So this was your, so the difference is that it's a clock, the pulse, positive clock pulse age. So the CLK refers to positive clock pulse age. Okay. So this operation is only allowed for a small amount of time. That is the time period for which we need to have a reset signal or a set signal. That's it. So it makes sense, because in the latch, the reset would be on for some time, set would be on for some time. Why would you want to do that? Why would you actually want to do that? You want a reset signal to go in and a set signal to go in. For example, if you have a toggle button in, let's talk about the toggle button in the TV again. If you put the signal in, click, and it's on, you don't want the switch to lie down. You want it to come up. So it's a mechanical equivalent of set being on for some time, which is happening in case of the latches. But in a flip-flop, this is corrected by making it an age triggered device. So when you set it, it gives a set signal, then that's it. Then you can read it again. And if it's a reset, then it gives a reset signal, and then you cannot read it again. This is how it works. So this is the SR